So with respect to deep learning classes, we have gone through different topics related to deep learning, mainly in terms of different kinds of neural networks, supervised, unsupervised. And we have gone through some of the algorithms with respect to deep learning, but we missed out the major concept of how deep neural networks works. Yeah, we know what are the number of layers present in it. What are the different kind of structures present in it? Yes or no? So what are the different kinds of structures we have in neural networks? Initial, how are they classified? What is the basic classification of neural networks, you can say? With respect to the structure. Okay, once it's there in the board, rub this things, okay? So basically, we started with ANNs. You remember that? What are ANN? What are the ANN stand for? Artificial neural network. How were the structures present in it? They also had input layer, hidden layer, and output layer. Okay, let me draw this input layer, hidden layer, and a output layer. So what are the major difference, or how was the data flowing in? If I take a convolution neural networks also, if I write CNN here, your convolution neural network also will have an input layer, and hidden layer, and then output layer. So what is the difference, or what is the major difference between these two? Yes, let me draw same structure. So what is the major difference between ANN and CNN? CNN stands for convolutional neural network. Okay. Now what happens here in ANN and what happens in CNN? Okay, we'll look at it. How they are different and what is actually, you can see. So these are the topics which we'll go to. What is ANN? What is CNN? What is CNN architecture? And some examples with respect to CNN networks. And what is convolution? In convolution, what's a dot product? What's a cross product? And finally, we'll look at recursive neural network. Okay. So the classification is not just ANN, CNN, not just two. There is RNN also. Where do you use RNN? What is RNN? Recursive neural network. Okay. Okay. So these are the three major difference with respect to the architecture, neural networks. Okay. Not only architecture, it has functionality also. What are the different functional items which are running inside? So look at the algorithms. What's happening in ANN? Basic regression and classification. Till now, whatever you did, okay, will come under ANN. In convolution neural network, both classification, regression, and other tags will come into picture and lead to an application output, mainly computer vision, like people detection, car detection, etc., etc. Those can be an example. In recurrent neural network, wherever time is involved, time series analysis, you go for recurrent neural network. Can you give an example of time series analysis? Your voice, speech analysis. Video, continuous time video analysis also can be done through RNN. Wherever it wants to remember the previous terms, your RNN will come into picture. Okay, even in your text detection also. What happens in text detection? You need to find a relationship between current word and the previous word. So at those places also, RNN will come into picture. Okay, so basically these are the three classification. Now let's move into first, what is the difference between ANN and CNN with respect to structure, function, and application, and then move into RNN later in the end. Okay. So your ANN can be called as a general purpose network. Okay, that was the first neural network which was introduced to you all or to the world of neural networks.
Yeah, when you are going by 4:30 or 5 o'clock, kindly close the window. At night time, due to wind, it is hitting with us. He was when you are going, at least one reminder that we should close the window.
Okay, so ANN we have done with respect to regression and classification. CNN we are yet to do the spatial data. What is the spatial data? What is the spatial data? Example of a spatial data. Example, if you take an image, okay, image is in a space, two-dimensional space. It's called as a spatial data. What is happening? There is x-axis and there is y-axis. What is this first pixel? Your first pixel is at 0, 0. That is x equals to 0 and y equals to 0. It's at some point in space. That's why it is called as spatial data. Now, example, take the last pixel here. What's the coordinate of last pixel? If image is m cross n, then it will be m comma n. It's m minus 1 because it starts from 0, no? M minus 1 comma n minus 1. Okay. So this is spatial data. Anything with respect to either one dimension, if you take one dimensional signal, if you take a speed signal, it will be something like this. It's moving with respect to some time or some quantity in 1D. This is 2D. Why 2D? X and Y are present. Why this is 1D? Okay. Time is the variable here. Here X and Y are the variable, only time is the variable here. Okay. If you take your art signal also, okay, it's also varying with respect to some time. That's also a spatial signal. So we can use CNN on any kind of data in the world actually, because most of our data varies with time or something else. It can be one-dimensional, two-dimensional, or three-dimensional. So we know that ANN has got multiple perceptrons. Okay, can be called as multi-neural network or multiple perceptron neural network. And ANN is also called as feed-forward neural network. Okay, this is very important. It's called as feed-forward neural network. Now the question is why? Why it's called as feed-forward neural network? Because when you give an input here, you give an input here, the input starts here and goes to an output here. It doesn't come back. There is no feedback or there is no backward propagation. Okay, so the data is processed only in forward direction. It is not fed back to the input at all. So that's the major difference between your ANN as well as CNN also. Okay, they pass through the information in one direction through various input nodes until it reaches the output layer. Now, what happens in convolutional neural network? We know we have images. I took an example of an image. Okay. Now, when you look at something or somebody, example, when you look at me, what do you see first? When you look at somebody, example, me, what do you see first? When you look at an image of a person, what do you get first? Oh, you basically get the outer shape, yes or no? Huh? Basically look at the shape, outer shape. So what are you doing? Edge detection, yes or no? You're trying to compare. How do you know that you're sitting in the front and somebody is sitting in the back? Basically comparison between background and foreground. How do you do that? Through edge detection. Okay. So same things are applied in neural networks also. And detection of those shapes, detection of those edges are actually done by convolutional neural networks. Got it? ANN simply process the data and try to get an output, compare the output at the output layers. Whereas what does CNN do? It does something extra. Okay. It applies something called as filters. Note down, filters are kernels. Usually, this will be the interview question. What are filters? What are kernels in convolutional neural networks? Okay. So automatically there will be around 32 or 16 to 32, 16, either 32 or 64 filters which are present at the convolutional neural networks when you apply CNN. Okay. Have you built any convolutional neural networks in your Python code? 4-layer, 2-layer, 3-layer. Have you used CONV function anywhere? I think you have done it in one or two problems. Okay. The major function to invoke your convolutional neural networks is CONV in Python. Okay. By using this function through Keras or something else, we can invoke convolutional neural networks. So now what is the difference between ANN and CNN? ANN is also neural network. CNN is also neural network. Tabular data can be applied on ANN, but ANN you cannot apply a image data or any spatial data. Why? Tabular data is just numbers. Okay. Whereas your spatial data like image is two-dimensional, where there is a relationship between one pixel and other pixel. We take an image, there are a lot of relationship between one pixel and other pixel. If we take this PPT only, see, this is a black pixel and the background is a white pixel. There is a relationship between those two. If you make this also black, background also black, what will happen? There is no information, nothing. There is no spatial information at all. So to retrieve these edges, black edges, your CNN is required. Alright, to retrieve the information from the spatial data, your CNN is required. So these are the major difference between ANN and CNN. So what do you see there? First, as I said, it's fully connected feed forward network in ANN. Whereas in CNN, what happens? Convolution will come into picture. We'll see what is pooling, what is fully connected layer later. What is a fully connected layer? Have you gone through fully connected layer anywhere? I've seen it. Guys, one layer, the neurons in one layer are fully connected to the neurons of other layer. Okay, let me take just an example of two neurons in one layer and three neurons in the other layer. And how are they connected? Okay, straight. So this is a fully connected neuron layer where all the neurons of one layer are connected to the neurons of other layer. So in CNN, what happens? We add a convolution layer as well as a pooling layer. Pooling layer is not like swimming pool. We'll see what is pooling. Yes, man, we can use, no problem. But it would be a waste of energy and resources. That's it. CNN would be enough for that. Okay. So neurons are connected. What do you mean by dense connections? Dense layers are fully connected. Since they are fully connected, they are called as dense connections. Whereas in convolution, they are not fully connected. Okay. Output of convolution layer will goes to pooling layer. You might skip some of the neurons in convolution layer, and hence it's a sparse connection. Okay. So as I said, simple regression classification can be done and tabular data can be used there. For image, video, NLP or text processing, we can go for CNN. Now, what do you mean by parameter sharing? Yeah. Parameter sharing. Huh? See, AN is something like, as I said, feed forward. You'll given some input based on the network, you'll get some output. Okay. You are trained the AN also to get some output, etc., etc. Whereas, what happens here is we can share the.
Is it the given input?
Sorry.
Given input shared across all the.
No. What happens is if you want to replicate a network or somewhere else, we can use the same set of parameters here. Whereas in ANN, we don't know what is happening inside. Actually, how the weight files are present or what's happening there. But if we give the same set of parameters in convolution as such, they will train according to it and you'll get a similar output as such. But in ANN, you might get an output for the first time, the second time you might not get it. You have to save that network and keep it somewhere else. but the same set of parameters, it works for two kinds of CNNs. That is called as parameter sharing. Okay. We know high dimensional data. As I said, image and video. Image is a two-dimensional data. Video is a three-dimensional data. Why it is called three-dimensional data? Why video is called as three-dimensional data? Interview question. Huh? Frames. Collection of frames. So what? Collection of frames means I got multiple frames like this. So what am I doing with it? Each and every frame has got X and Y axis. So how it is three-dimensional data? Here we saw an image has got X and Y and it's represented by the pixel coordinates. Now, why do you call a video as a three-dimensional data? Right. Your X and Y data will be like this. This is Y and this is your X, but it will be varying with respect to time t. The time is the third dimension. Okay. If time is the third dimension, it's called as three-dimensional data. As the number of dimension increases, the complexity of processing those data also increases. Okay. Local receptive fields. We'll see this when you go into CNN later. Next, example architecture. We know we have seen feed forward network, simple ANN also, simple neural networks also. And what is MLP? Multiplayer perceptron. What does multiplayer perceptron contain? Input layer, hidden layer, and output layers. Okay. Whereas in CNN, to process your spatial data, we'll look at ResNet, LeNet, LXNet, VGG. Have you ever heard of this? YOLO? Okay. These were the forefathers of YOLO, you can say. Okay. Before YOLO 1 came, YOLO 2 came. These were ruling. Big CNN network. Later on, YOLO came into picture. So as I showed you an example, this is an example of ANN and CNN. Okay, what do you see there in ANN? They are fully connected networks. What is happening in CNN? As I said, there will be a convolution layer, there will be a pooling layer, and you can see there is a repetition again. You can have multiple convolution layers. Again, another set of convolution layer, and then fully connected layer will come into picture. And then finally, your output predictions. Okay, now the question should come into picture. There was a single image, suddenly a three-layer image came into picture. How is that? Flattening. One image and three images here suddenly. What is happening? Hmm. And there's a convolution layer. That's one thing. An image contains RGB, R, G, and B. But since it's a convolution layer, what am I doing? Filtering. Or I'm doing convolution using a kernel. So I've got three kernels or three filters, you can say. When I apply those three filters on the input image, I'll get three more outputs. Right? What does pooling do? Reduce it. Okay, take only the important terms from it. Pooling. So in a pool, you pick up some students for the interview based on their marks or based on their talent. That is called as pooling. Here also, only important terms in a given convolution layer are picked up. Okay, what is convolution? Getting edges from this. What do you see here? you can see the outer shape, no? By applying a high pass filter, I'll get edges in one image and foreground in another image, a background in some other, the third one. It's only extracting information, and most of the output of convolution layer is grayscale. You don't see any color inside there. It will be completely grayscale images. All right. When you look at somebody, human perception mainly, you see the outer shape, no? That is actually through grayscale analysis. Human brain also does a grayscale analysis, not color analysis. Yeah, finally you want to say it's either a daisy or a windflower or sunflower or a pansy, no? So your output last classification is just 4. So you have to create all this network to give an output of what kind of flower is it? Right? We'll see one by one what's happening in convolution, what's happening in pooling, and what happens in fully connected layer. In fully connected layer, what is the algorithm we use? Remember that? In order to get probability, in order to predict different probabilities, what is that algorithm we use? We use tan H, we use ReLU, etc. Convolution layers. And the output layers, what do you use? Softmax. Okay. Softmax is used at the end of the fully connected layer in order to give different probabilities of prediction. Okay, interview question again. What? You finished interview? Last slide, huh? Okay. It is not much, man. Basically, in order to start with convolution layer, we have to start at some point. First, they took a human brain as a neural network. They started with y equals mx plus c, later on neural network, then ENN, then MLP, and then CNN later. Started in 1870s or something like that. Within those 100 years span, we came here. 1990s, CNN came into picture also. Okay, that's how far or how much time it took to reach there. Have you seen that 3-body problem, no? 3-body problem. Watch it, it is nice. Huh? It's a series, sci-fi series. Then you study, man. No time. There he speaks about the human evolution. How much we took, how much time we took to invent a wheel. First with fire, then wheel. Then your abacus in China. Later on, your computer came. From computer to here, how much time do it took? Current AI. Not even 100 years. Ah, 50 years, that's it. The technology is increasing exponentially. In within 20 years, will be, I don't know where. Moon, Mars, anywhere. Yeah. If we don't work properly, or if we don't work hard, we'll be burning only. So this is how the evolution is going on. So this is the pace we have to catch up with. If we take the internet world itself, it shows that how you people are manipulated, how everybody is controlled through internet. Alright, it's all algorithms. Each and everyone in the world, let it be US elections or India, is controlled through internet. Everybody is controlled. Not even a single fellow. You are controlled either by YouTube videos, you are either controlled by Google search, either by money, like entrepreneurs. Somewhere or the other you are controlled. Okay. US wants India to be gone within 1 month. This, yeah, that's all algorithms are running. Each and everything is an algorithm. You click, just click is an algorithm. The feedback is gone. They will simply spread some religious things, then done. That's how Bangladesh went into fire. Whole nation was gone within a month or two. That's how powerful the internet are. That's how powerful the other countries are. We are nothing. People don't know this. Okay, so let's go into convolutional neural network architecture overview. So what do you see here? As I said, it mainly contains convolution layer, max layer, and dense layer. Dense layer means fully connected layer. Okay. So where does the filter comes into picture? Here, convolution layer. All the filters are present in convolution layer. What does the pooling layer do? It will downsample. Okay. Next, what does fully connected layer do? It's mainly used for prediction. That is, if you want to predict only it's a cat or a dog, what do? You will have just two output neurons. Okay, there will be thousands of neurons just connected to two output layers, cat or dog. If you add giraffe and elephant, there will be four outputs at the fully connected layer. All the neurons in the next layer are connected to this four neurons at the output layer. Okay, softmax will be running. Whichever has got the highest probability, that will be picked up, either a cat or a giraffe or an elephant or a dog. Okay, so these are the four important layers in a given CNN architecture. So why do you have to use filters? Why are you using filters? See, man, if you take online retail data, your tabular data, each and every column is a feature. If you take an image, where will the feature come from? Each pixel is a number. Okay, what does an image contain? If you take an image, it contains set of pixels. That's the numbers. Yes or no? Yes or no? You know that now. If I take an image of 5 cross 5 here, okay, each pixel is a number. 100, maximum will be always 255. Minimum is 0. Okay, let's put some random numbers. Put a dark line here. So this will form an image. It's a 5x5 image. This is how a 5x5 image numbers will look like. Starting from 0 to 255. 0 means black pixel, 255 means white pixel. Install whatever comes in gray. This is a grayscale image. How do you make this as a color image? You need 3 more layers, 2 more layers. Add 2 more layers of 5x5 and provide this to R, provide this to G, and provide this to B channel. You'll get a color. All right. So this is how we get an image. It contains R, G, and D, and this data goes input. Now, with just numbers, what do you do? How do you get the picture with numbers? Numbers are there randomly placed somewhere. We have to use filters in order to get background and foreground difference. Adjust mainly. Okay. In a given convolution layer, there will be around, as I said, either 16 filters or 32 filters or 64 filters. You can choose a number of filters also. Now it's by default, it will be around 32. And choose your own filters. Based on that, you'll get some layers. You have to provide them to the next layer. That's how the procedure goes on. But what do filters do? Extract features from an image. Okay, that's the main purpose of filters. Alright. So these convolution layers, filters are also called as kernels. They extract feature maps. Now let's go to pooling layer. You will get confused with respect to pooling layer. So let me take another color here. So what happens? Let's apply pooling to this layer itself. Let's think this image is being convolved and you are getting some layer like this, output like this. Now, how do you apply pooling layer? Yes. Example, in pooling layer, what happens we do is we always try to reduce in pooling layer. So we have to pick only important pixels on it. Example, let's take max pooling. So what happens in max pooling? I want to reduce it to this image by half. So what I'll do, I'll take this first 4 pixels, which has got the maximum value 100. I'll write down 100. Okay. Next, I'll shift to next set of pixels, which has got the highest pixel here, 50. I'll go to next set of pixels. How many pixels are there? Which is the highest? 255. And here, 255. So this will be max pulled out. From 5x5, I'm gone to 2x2 by half. Okay. This is called as max pooling. There is absolute pooling also. There is minimum pooling also. There are different pooling layers, but max pooling will always give you a better result. Now let's go for max pooling. Okay, so this is the second layer of your convolutional neural network. And you have seen fully connected layers or dense layers. Okay, they usually are present at the end of the neural networks. This is how CNN was designed. Filter, pooling layer, fully connected layer. Okay. And of course, other than the fully connected layer, some of the important terms like activation functions. What do activation function do? They introduce non-linearity. Got it? Since convolutional output, max pooling output, or linear outputs, we use activation functions like relu, tanh, sigmoid function in order to introduce non-linearity into the system. Okay, of course, normalization in order to stabilize the data. We don't want 0 to infinity. We want 0 to some fixed set of values. We go for normalization. Okay, so these are the most important components of convolutional neural network. Okay, so this is one of the example images I got in the net. Same thing which I showed in the last example. Convolution max pooling. Yeah, I wanted to say this. In order to introduce just one convolution layer, one max pooling layer, there can be multiple convolution layers and max pooling layer combinations. Got it? How many layers of convolution layers are here? Two. There are two layers of convolution layer. We have maximum got around 108 layers. In ResNet and all, you can go for 108 layers of convolution and max pooling layer combination. But it will slow down the training process like anything. More the number of layers, slower the training. It might take days, it might take sometimes weeks. Okay. So when I was working in my Chinese company in 2018 in China Shenzhen, there we had rows and rows of computers with different parameters tweaked, and all these codes were running. There will be 10 convolution layers, somewhere there will be 20 convolution layers, and somewhere some parameters were tweaked in order to get the results. That's how the testing went there. They had huge resources. They wanted to learn. They wanted to get some output. They wanted to check which was the best. Mainly that was a trial and error case. Okay, the amount of brains used were less when compared to the American counterpart. But it was simply a trial and error process. Okay, still they learned. That's why so much competition is there. They are not using any formulas. They are not using any thinking power as such. It's brutal trial and error. That time, not supercomputers, normal computers only with graphics card. In a room, there we have what do you call apartments, no? They're given it for free for the company. They don't have any buildings and all. The whole apartment is one company, or one whole floor is one company. From this end to that end, all computers running. That part is also cold. No need of AC also. Just open the windows and keep it. Each and every computer has two graphics card, NVIDIA graphics card, and codes were running. 2018, how many years? 6 years already. Now they would have been somewhere else. Okay. So, and this is how a fully connected layers looks like. So each and every neuron of a previous layer is fully connected to the current layer. Okay. And you can see there's a face coming into picture here in this image. Might be Abraham Lincoln or somebody. And this is how the pixel will look like. Okay. What do you see here? Pixel values. Yeah, you can see white pixels are 252. Dark pixels are 10, 11, 10, 6, etc., etc. Yeah. How many pixels does your phone contain? You don't know the phone. Not camera, your screen. 680 pixel per inch PPI will come into picture. So many pixel in an inch area. 680, 650, that's a common series. Now that I want to move. Yeah, but the problem is refresh rate is also required. It's at 120, 144, but the problem is power taken will be more again for this. So usually reduced to 60 hertz in iPhones. They are little intelligent. Your Samsung and all gave 120, they moved, but the amount of power which you taken will be high. But if more refresh rate, sensitivity also will be more. Just touch it, it will go. Not even touching is required. So this is where we are. All got it now? How white pixels are represented, how black pixels are represented. So let's take an example here. Okay. I want you to code this. Yeah. I want you to take a color image of 32 cross 32 pixel. Okay. Then apply it to a convolutional neural network where it will contain convolutional layers. Okay. So usually what happens, your kernels or filters can be either 2 cross 2, 3 cross 3 or 5 cross 5. But the standard used is 3 cross 3. Okay. You can pick the size of the kernels also. You people have got inbuilt codes like CONV, but we had to code in C programming. Okay, we took kernels 3 cross 3, 5 cross 5, etc., and applied our image on it. That's how the situation was there. We didn't have Python or all these libraries during that time. It was just OpenCV, C coding, C++ coding. And debugging was a major headache there. Debugging the code itself used to take a lot of time. Okay, so we'll have a kernel, we'll have an image. This kernel will be of 3 cross 3. Okay, it will be something like -1, 0, 0, 0, 1. This will be 1, 1, 1. This is how your kernel will look like. 3 cross 3 kernel will look like. When you pass this image to the kernel, it will give you edges. Here you can see there is a change from negative to positive here in horizontal direction. So we'll get only horizontal edges. If there's a change in vertical wise, we'll get vertical edges. Similarly, similar to this, there will be 32 filters in the given convolution layer. So your output will be this image into 32. Okay. So here we have taken 12 filters. So your output of that convolution layer will be 32 into 32 into 12. Note it down. This is very important. This is a convolution layer maths. Input image was thus 32 cross 32 cross into 3. In layer 1. That is input layer. That was the size of the input image. Next, what you have to do? We need to extract features. What do you do? we send it to a convolutional layer where kernels are present. The size of the kernel here taken as 3 cross 3. Okay. How many kernels are there? How many filters are there? How many filters are there? Well, okay. There are only 12 filters. So the output of this convolution layer will be 32 cross 32 into 12. Yeah, you can calculate what is 32 cross into 33 into some number. But this is 12. As I said, we send only grayscale images for filtering. We don't send color images. So 3 is removed here. We convert this color image to grayscale first. Okay, that grayscale information is sent into the filters. Somebody was saying you had this as interview question. Who was that? Navya. Which interview? So you should be prepared before. Come regular, everybody come to the class regularly.
The role was on software engineers.
Ah. Yeah, as soon as you say yeah, engineers, first question will be on CNN.
The non-stress conceptual question. Because our stream is on animation. That and all.
You want answer, huh?
Only for me now.
What are the questions?
So, what is computer vision in AI?
What is computer vision AI?
AI in everything and everything in AI.
Same question, sir.
Yeah. And the face recognition thing he asked.
What did they ask in face recognition?
So he asked in computer vision, audio, for audio processing, can you use finger using it?
Where is audio? Where is fingerprint?
It's not good. It's not second. He was arguing that. Yes, use it. We can use it. I said, no, how can we? He was asking.
Might be what he's saying that what happens in fingerprints, you know? It will be something like this. Use of fingerprint. Okay, what you do is we convert this data into single lines. So it will be something like this, pixel wise. All right. This will be pixel wise data from this to here is taken with respect to time. That's what he meant, I suppose.
So
He was also new to AI, I suppose.
If the person get headache, how can AI tell that? Because
Might be he was working on face recognition. We can use, you can say face recognition.
yeah. Give example saying that when ಅದೇ ಸರ್ ಲೈಕ್ ವೆಬ್ಸೈಟ್ ಅಲ್ಲಿ ಕನ್ಸಲ್ಟ್ ಮಾಡೋದಿದೆ ಅಂತ ಲೈಕ್ ಇಫ್ ವಿ ಸೇ ನಮ್ಗೆ ಹೆಡ್ಡೇಗಿದೆ ಅಂದಾಗ AI will give you like what are the tablets you can take ಅನ್ನೋದು ಹೆಲ್ತ್ ಕೇರ್ ಅಲ್ಲಿ
He was asking if you got an headache,
AI will detect.
I will detect. Heart sentiment, man. He wanted mainly face recognition part by looking at your eyes, images. Or if you take tongue also, if we can see if you got infection on the tongue or not, also that's also possible. Mainly, since he asked face recognition, you should have told you can do face recognition, look at your eyes, look at the color of it. What happens when you get an headache? Your eyes will be red or it will be swollen or gone inside. Take the image of your tongue then. Not except tongue images. That's how doctor come to know. No, you got a throat. You're not talking about COVID here. No. Headache question is one thing. She should have said, sir, if I got an headache, I will tell that I have a headache. Why does AI want to detect that? I am more intelligent than AI, no? What?
Human is intelligent. I said human only, sir. What input we give to ChatGPT or whatever model is there, and the output of it. And he also agreed for that, sir. Like he gave one example for that. If we tell AI to give how to prepare a cake, how to bake a cake, it will give the step, but it will not prepare and give you the like that. Some example he gave.
You simply wasted time, I suppose.
No, sir, we had. Thanks for the question.
Very selected.
So we will get that in next month, next time.
HCL, huh?
It is for 21 next year, sir. Next year after ಕೇಳಿದ್ದು sir. HCL update ಆಗ್ತದೆ. HCL.
Which company?
LTI.
LTM entry. Okay. Try to get a better one before.
All the ingredients have been set in machine. You know that packet cakes which you get Britannia and all of that. You know the cakes, right? You know that. That's all machine made. It's not.
But the info should be given by reverse review. No, machine can't prepare.
That's why the taste is so bad, man.
But it is. But see, the perfection is same, right? It gets packed in a perfect package every time. In 100 packages, maybe 10 will be rejected. The 90 have been made, right? If a human is making it, it's gonna take more time.
See, one thing I know, always try to go for fresh cakes. You know how many preservatives they will add in it. So what I understood with industrial revolution is anything which is done in bulk is not good for it. Anything which is done in like chips packet, cake packets, whatever it may be, anything done in bulk is not good for it because they add a lot of preservatives to it. If you take puliogre also, the packaged puliogre, that's very bad. A lot of preservatives are into it. Your mom would have made it. No, leave it. Because puliogre, after 10 days, the taste will go. If you get male kote puliogre also, the taste will go within 2 days itself, packaged. And these people are packing it months together. Huh? So what they do is they'll add some gas actually. Huh? It's not Blair, they'll add ethane gas and that is carcinogenic. Ethane gas is actually carcinogenic. That's why most of our spices packets were rejected in abroad. Excessive use of that gas, which is carcinogenic to preserve. Okay, so eat healthy, eat fresh things. Don't eat packaged foods. Okay, next we have seen activation layers. Okay. So at end of each and every convolution layer, there will be activation functions. At each of end and every end of each and every convolution layers. So the output will remain the same. That is 32 cross into 32 into 12. Output won't change at all. All right. So what does our activation layer do? It introduces non-linearity. Okay. So it can be ReLU, TANH, or sigmoid. Okay. Next layer is pooling layer. What happens in pooling layer? As I said, I'm taking a stride of. Look here, before that, I have to take stride. Stride means by how much I'm compressing or how much I'm reducing the original image. Here, stride will be equal to 2. Okay, and the filter chosen here is 2 cross 2 filter. 2 cross 2 filter means similar to this. How many pixels are here? Cross 2. Yes or no? In the original image. The original image, I'll take 4 pixels. 2 into 2 is 4. So this is 2 cross 2. Out of this 2 cross 2, I'm applying max pooling on it. When I apply max pooling on it, I'll get this image. The whole image will be divided by 2. So the stride of 2. Stride will be equal to 2. Pardon? This reduces the image or the feature image by half. So 32 into 32 will be reduced into 16 into 16. That's what stride means. Completely divided by half. Okay. It's a 5 cross 5 image here. If I take 4 cross 4, my output will be 2 cross 2. But from 4 cross 4, it has become 2 cross 2 in this example. So same thing happens here. 32 into 32 will become 16 into 16. Note it down. Given the example, note it down. It's not Sir? Recording the class. Recording. How many hours?
1 hour 3 minutes.
Right, I thought I forgot to record. Who started recording anyway? I didn't start. Good. I started. Okay, so this is the example of max pooling. The same example, you can see the maximum pixel in the given first 4 2 cross 2 is 6, 8, 4, and 3 here. Okay. So this is one of the example of a car. I don't know which car is this, but this is how the convolution layer output will look like. Company. So what do you see in the convolution layer here? Everyone, look here. Color image, your convolution output. How many filters are there in this? It's convolution layer. I'm talking about filters. The convolution layer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are totally 10 filters coming into picture. At the end of each and every convolution layer, there will be ReLU. What is ReLU? Activation function. So what? Look at the output. What's happening? Non-linearity introduction. Okay. So 1 layer, 2 layer, and after that max pooling. In max pooling only you will get white pixels. Similarly, after 2 convolution layer, you can apply max pool layer also. In the end, what do you get? FC. What is FC? Fully connected layer. Your fully connected layer will have the highest probability through softmax. Okay, so this is CNN. Any doubts in this? And those are your CNN works. Okay, and there are some other terms. What is flattening? You have to all remember these terms. What is flattening? Somebody said flattening earlier. Not flattering, it's flattening. If you take this image, okay, how do you flatten this image? Two dividing nothing. You have to convert two-dimensional data to single-dimensional data. 100, 10, 10, 0, 1, 20, 30, 50, 0, 1, 200, 255, etc., etc. So what have you done here? Hey, Abhinav, what is flattening one?
Reducing two dimensional, one dimension.
One dimension. How do you do that?
And
Uh-huh.
converting it.
Look here. There's the image. What am I doing? I'm plotting it in column wise.
Converting it to.
First, I'll take the rows. First row, second row, third row, fourth row, fifth row. This is how the number will look like. This is called as plotting. You can do it in row wise also. Just put a transpose of this of column, you get a row output. Okay. So this is flattening. And you, of course, you know what is fully connected layer. It's either finite classification or regression layer. And at the output of the fully connected layer, what do you get? We need a logistic function for classification task. Okay, so use softmax, which converts the output to probability score. So what happens? Softmax okay, look here. In softmax, what happens is if I have an output of 1.1, 2.3, okay, your softmax will add up these two. How much I will get? 3.4. So you have 1.1 divided by 3.4 and 2.3 divided by 3.4 will give you the probability amount. Okay, that's how simple the softmax works. And you can apply sigma also later after this. Before softmax, or actually it's before softmax. Sigma and then softmax. Okay, so this is one of the animations you can see. This is how convolution is happening with respect to the given data. So we'll look at convolution in depth mathematically as well as how it is working. How are you going to do a convolution of an image with a given kernel or filter? Okay, what do you see here? It's not moving. Huh? What do you see there? This is your input image. Okay. This is your input image. Now you can see a kernel here. This is your kernel. This is a sharpening kernel or a sharpening filter. Your kernel is applied on this image, and this is the output of one image. What do you see? See, simply multiply, align the first pixel with the middle pixel of the filter. After allowing, simply multiply the other values. Then shift your filter to the next middle value. That is your 6. You should be in coordination with first 7, next 6, then with 5, etc., etc. Then go on multiplying the neighboring values. Origin 5 and 7, 5 and 6, 5 and 5, 5 and 5, 5 and 6, 5 and 7. Every pixels. Okay, let me take the first example itself. Right? You have some water with you here. Whenever something is written on the code, please rub it on the same day itself. Okay, you can take a photo and rub it. Otherwise, it won't go later.
You will match, you will clap to the boss.
Okay, tell me the pixel values of the first 7, 6, 5, 2, 4, 6, 4, 3, 5, 3, 2. Okay, these are the first 9 pixels of the image. What is the kernel value? 0, minus 1, 0, minus 1, 5, 0, 0, minus 1, minus 1, 0. Yeah. So this is a filter actually. Whenever minus comes into picture, it's a edge filter. Okay. Now what do you do? I need to start filtering my image. I need to start from first pixel. So I will align my kernel and filter here. For the first time, my kernel and my filter are aligned like this. So this will be 0, minus 1, 0, minus 1, 5, minus 1, 0, minus 1, and 0. Okay. Now go on multiplying. 7 into 5. Any pixel values are here? No. So we forget these pixel values. All right.
7 into 5.
All the values in the neighboring cannot be multiplied because there are no pixel here. We have to align with this value first, the first value. So it will be 7 into 5 plus 6 into minus 1, 4 into 0 plus 6 into minus 1. How much do you get? Minus 12. How much is this? 21. But what did you get there? 5, 9.
Sir, we have taken 7 and 0 as 0.7, 6, 20 into minus 1.
No, we are getting 0.7 here, not 9. Sorry?
25 minus 12 is 23. Fraction.
23.
We have to divide with some value.
So see,
Yeah.
they're taking some decimal numbers here. See 0.7 minus. So that means what is that middle one? 0 minus 1 0. ಅದು ಕರ್ನಲ್ ವ್ಯಾಲ್ಯೂ ಅದು default they are taking and sir the kernel value is default or what, so that we have to take how will it takes
What kernel value? What
that
is
middle one 0 minus 1 5 minus 1 0 minus 1 0 why that's up
that cannot be passed as a GIF image. That's a GIF image. Okay, do you understand what is happening here? 0 into nothing. 0 minus 1 into 7. These won't come into picture. It will start from 5 into 7.
so why
This is kernel I'm talking about. No, we have to give. But when you put convolution, there will be, what do you do? Into 12, no? 32 into 32 into 12. It's one of the filter here. Okay. Out of the 12 filter, this is one of the filter which is present there. Alright. So you can see first 0 into something doesn't work, into that doesn't work, but it is 5 into 7. Look at the calculations here properly. Are you getting the same answer or what? 7 into 5, 6 into minus 1, 6 into minus 1. Is changing that or what? Okay, go to the next pixel and see what happens. Go to 6 pixel here, multiply and see what happens. First take the first pixel, next take the pixel. So,
That's 3 by 3 matrix.
sorry?
Consider it as 3 by 3 matrix.
Yeah, I think there is a division factor also coming into picture here.
And matrix multiplication there, not just the output field. It is multiplied by 0.7. So they are taking not the number divided by 100. So 7 will become 0.7. Yes, sir. Try 0.7 will become 0.7 into 1 into 0.
To 5.
So it will become into 5, which will become 0.7 into 5 is how much?
0.7. 7 into 5 directly comes into picture here. So this is how matrix multiplication happens. It's direct.
They're taking 0.7 and into 0.
That's not 0.7. 0 into 7 is.
0 into 7 is 0, but
Hmm.
they're taking 0.7.
First one is 0, 0, 7, 7, 7. Next 7 into 5 into
Yeah.
picture, you have to just add it. But how he is getting 9, I don't know.
Taking the full matrix and then totaling actually the right side below.
Did you miss out something here with respect to the matrix? Not full matrix. For the first pixel,
Yeah, first pixel.
Ah,
First pixel matrix.
you're not understanding.
You can't pause it, it's a thing.
See, I'll overlap it on this. You'll understand it in a better way. So this is what he's doing. 0, minus 1, 0, minus 1, 5, minus 1, 0, minus 1 into 0. You have to go on multiplying it and adding it.
7 multiplied with 5. Then
So that's what 7 into 5 is 75 plus minus 6 and minus 6. So this is the 12th one. So now let's go to the next pixel and see Is dividing by some value, that's fine, that's okay. But this of matrix multiplication or convolution will work. Now let's shift here. So this will be 0 minus 1. Matrix multiplication is this. Why? What's the problem? 0 minus 1, 0. Can you calculate the second pixel now? 7 into minus 1, minus 7. These are all 0. There is nothing present here, so we ignore this. 6 into 5 is 30 plus 30. Then minus 5. So what's happened? 0 into 6 is 0. This is minus 4. This is 0. So what do you get? That's fine. What is 35 minus 12?
23. Huh?
Yes.
35 minus 12. 23.
This is 23. How much do you get here? Minus 9, minus 16, 30 minus 16 will be 14. How much we are getting there?
Okay.
Minus 40. 23 minus 40. 9. But there's something with divisions.
Yes.
No, we usually what we do is we divide it by some factor here. He has not given the factor there. I'm thinking which is that factor. I'm trying to divide by 9 divided by might be he has given out random numbers, but these are the numbers we are getting there. Might be those are wrong numbers actually. Okay. But these are the numbers we'll get. This is how matrix multiplication is done and convolution is done. Yeah, he is doing the same calculations, but he's getting a different number. You see, when you add up these things, we won't get 9, we'll get something else. Okay, this is convolution. Convolution is done through matrix multiplication. Now let's move on to the next part. What happens in convolution? What is dot product and what is cross product? Heard of dot product and cross product? What's the difference between vector and a scalar? Hey, we'll see an example there in convolution. Okay, but that's how convolution works. Don't worry about it. Okay, let's come to dot product and cross product. What's the difference between a vector and a scalar? Vector has both magnitude and direction, whereas scalar magnitude. Example of vector and example of a vector, scalar. Gravitation pull will be here, no? Weight into gravitation will give you. See, if you take yeah, but the problem is gravity is constant. Okay, if you take this phone and this pen, if you drop it, both will drop at same time.
Must.
Doesn't matter. If you drop a feather and if you drop a bowling ball, Both will fall at the same time.
No. Center will fall slow. Yeah.
In a vacuum.
No.
In a
If
vacuum,
I throw a pen and a paper, which is gonna fall first?
both will fall at the same time.
No.
We don't have a vacuum. We don't have any resistance.
Just see here.
That's due to resistance of air.
Oh, sir, but generally weight is
I'm
actually.
telling you, gravitation is constant because of the constant factor.
Weight is a scalar.
To become a scalar because both will fall at the same time. No, let's not go into physics. Okay, let's take acceleration. A bike acceleration. You're moving in a bike. If you accelerate, you'll be accelerating in some direction. No. Yes or no? So acceleration is a vector. Okay. Now edge. Let's take an edge in image. What has happened to the edge here? It's moving in this direction with respect to some vector. So it has got both direction as well as magnitude. If I take only one pixel, it's a scalar quantity. 100 is just a scalar quantity, but if I define x and y axis, it will become a vector quantity at some point. Okay, now let's not go into physics terms or something like that, but it's good to understand. As I said, there are two quantities mainly, dot product and cross product. What we are going to use here is only dot product. Your convolution uses dot product. Okay. The formula for it is here given out. Dot product is also called as scalar product. Why it is called scalar product? Because output is a scalar there. When you multiply two vectors there, two vectors here, what do you see here? There are two vectors. Vector 1, vector 2, vector A and vector B.
We get scalar.
We can get a scalar or you can get a projection also. Projection of vector A onto vector B is given by dot product. Okay, how much is given by a scalar quantity? The formula is given here. A into B into cos theta. Whereas in cross product, what do you get? You get a vector. Output is a vector. Comparison of vector A and B will give you some new vector. Okay, this perpendicular vector is the output of these two vectors. That's your cross product. That's why you're not taking vector into consideration here. We are taking only dot product into consideration here. Okay, a scalar quantity. So when you multiply two values here, thus 5, 7, 6 and minus 1, etc., output is a scalar number. Okay, so that's how you are getting. So vector are not concerned in the convolution. The directions are not concerned in convolutions. So dot product we use dot product in order to get a scalar number. And hence it's complicated in one-dimensional convolution when compared to two-dimensional convolution. Okay, in one-dimensional convolution, we use this complicated formula. What is one-dimensional data? The voice, heart signals, or medical signals are one-dimensional data. We have to apply this complicated formula on that one-dimensional data. When it comes to images, it is matrix multiplication. Okay, from this complicated formula, we can go to simple matrix multiplication in convolution when it convert one-dimensional to 2D. Okay, by using dot product. Okay, so this is how complicated it is in discrete time. You have to multiply and then add, multiply and then add. And this is how the multiplication will look like. This is a one-dimensional data, x of n. This h of n is your filter. Okay, When you apply convolution on x of n and h of n, this is the final result you'll get. And it's a huge set of numbers. Okay, so gist of the story here is convolution in two-dimensional is simply matrix multiplication. Okay, the dot product makes your life easy, converts your complicated convolution formula to matrix multiplication and two-dimensional signal. You'll be doing all these things in computer vision also. Okay. So next is RNN. What's the difference between CNN and RNN? Okay, talking about the difference. Temporal information or temporal dependencies or previous data is utilized when current data is processed in recurrent neural network. Okay. So if I take a neural network like this, set of neurons, what happens in RNN? Everyone, look here. What happens in RNN is there is a feedback or a memory which is attached to each and every neuron. Okay, what does this memory do? It will say the previous terms. What do you mean the previous terms? What do you mean previous terms? N minus 1 terms. What is n? Time or iterations you can say. At nth iteration, your n minus 1 will be fed back at each and every neuron. So that's how RNN are different from the CNN. Previous values are saved and fed back for the current processing. That's why they have temporal dependencies present in them. Okay. So what happened was in LSTM, what you know what is the full form of LSTM? Long short-term memory. Okay. So they saw that short-term memory was useless. It was not yielding good results. Not useless. It was not yielding good results. That's it. So what they did was they took long-term memory into picture. Now, what is short-term memory here? Can you tell? Can you tell you? The feedback loop which is coming into picture here is the short-term memory. That is the previous term. Coming into picture is the short-term memory which was taken into neural networks, which was not enough. So they went for long-term memory also. Okay, so this is RNN. Of course, backpropagation concept is also present here. But one of the major problem of RNN is vanishing gradients. Heard of vanishing gradients? What are vanishing gradients? Asman Samarth, very important for you. What are vanishing gradients? In neural networks, vanishing gradients. What are gradients anyway? Comes in backpropagation actually. Gradients are the data values which results in loss function, which are used in loss function. In loss function, will tell you how much weights and biases to be updated. Okay, so that is mainly given by the gradients actually, based on the gradient values. So what happens here is What happens here? Those gradients will become 0. First of all, gradient values are low, very low, 0.1, 0.2, 0.3. When you try to back propagate them, sometimes they go for 0. When they go for 0, you cannot update weights, you cannot update biases. So everything goes for a toss. So that problem is called as vanishing gradient problem in a given network. Okay. Then that's it. You need to apply convolution neural networks on your digit systems. Super and very good. What are the data set we had? Digit data set.
MNIST.
MNIST and SIPR. MNIST you have done, apply on SIPR. CI apply. Okay, that's the assignment. Okay, SIPR will have a size of the image 32 cross 32. Take those images. Apply convolution neural network. I want at least 5 convolution layers with at least 2 max pooling layers. Okay. Do it now. Take SIPR dataset, or okay, take MNIST dataset itself. Apply 5 convolution layers, 2 max pooling layers on it, and see what is the classification results. And I want you to print. Okay. Want you to print size of each and every layer. Output size of each and every layer. Okay. Should I type the assignment for you or what?